I think we need another lamp right here. Let's see. Okay, guys. So let's begin. Welcome to chapter 10. We're gonna talk about circles. I've been trying to change the setup to make it more comfortable for me. Hopefully, let me know if you have some issues as you see the board and as I, write stuff or draw stuff. Well, I hope you had a fantastic break, and I hope that you are doing well with your other assignments in your, other classes. I'm just going to say a few words about what we are going to do in this chapter 10. Basically, it's understand those theorems and those concepts is by, certain exercises where you have to find missing values. It's pretty much, and again, hopefully now you understand how this thing works, and it's kind of like a repetitive exercise, right? So this time we're going to repeat the exercise of learning new concepts and new vocabulary and practicing that, solving certain exercises to do this time. All right, but let's begin talking about parts of the circle, some vocabulary that is going to work on the problems or the exercises. I think I would recommend that. Yeah. So I'm going to give you 30 seconds to do it. We're on, chapter 10. Hopefully, at this point of time, I hope nobody has issues on having access to the book and everything, right? That is on page 574, pretty much, where we see all that. Okay, so let's begin talking about that vocabulary we have to use on circles. And let's begin by you guys, if you want to type on, on the chat, if you want to, I think that you have the option to unmute yourselves as well to tell me, and we are going to complete this, So for example, this is circle, and this is the way we say this. It's a circle O, because O is the point where the center is, okay? So we're going to identify some of those parts of the circle that we are going to be using throughout this chapter. So take your time, take a look at this. This is the very first part of this chapter. If you want to, all right. So let's begin with, probably I'm going to ask questions, and if you want to type it on the chat. Let's first identify this segment, AB. It has a name. So I'm waiting. So what is the name of the segment AB? So actually, this is what we're going to do. AB, then we can do, for example, OC. So yes, great. It's a simple thing, but anyway, I want you to participate because sometimes I feel a little bit weird by here talking alone in this room, and yeah, it's good to have this kind of interaction. So great, I see that. So yeah, we're talking about the diameter. How would you describe the diameter? Is a segment that connects. Who said yeah? OC is the radius. Okay. Now let's continue. Also, let's go with DE and FG, and finally H line, and FG is a line as well. All right, so waiting for your answers, guys. Well, the others, what is H or what is DE? All right, DE, I see I and H. We're basically going to deal with all these, right? With these ones. There are other parts of the circle as well, but for now, this is what we're going to do. So what else? I'm waiting. You can check from the book. or from any other website. What about FG? What about HI? All right. Okay, no problem. If you don't get it, I can tell you, right? So, oh yeah, thank you. FG. I can read it. Yeah, secant. Okay. FG is a secant. H is a point. Yeah, is this point of tangency. All right. And this line HI is the tangent. Good job. Okay. So I want to make sure that you are familiar with this vocabulary, because again, every time we start a new chapter, we try to get familiar with the vocabulary, so you are, we're all on the same page. Okay. And now from there, then we are going to determine some concepts, some theorems that come from these type of exercises. Okay. Well, so I had prepared one of these exercises from the book, but since we already did this, I guess that we're good with this part. Now we are talking about section 10.1. What I'm currently doing is part of section 10.1, right? We're determining the vocabulary and so on. Okay. Well, of these elements, right? So a radius, for example, is a segment that comes from the center of the circle to any of the points of the circumference or the circle. A chord is a segment that connects two points from the circumference, but you don't need more thing. I need you to pay attention to point H, which is the point of tangent. We're going to have O right here. I'm going to draw this radius OH. So I want you to notice something. Take a look at O. It means that they form a 90-degree angle here. They're perpendicular. And that gives us some interesting information, okay? Because let's take a look at this point I from the line HI. And I'm going to draw a segment that goes, and from there, from that segment, now we have formed a triangle, okay? A triangle with vertices OHI. And as you can notice, if this is 90 degrees, this is also 90 degrees, all right? So take a look at this closely, because we are forming the triangle OHI, and it happens to be a right triangle, okay? And with that in mind, let's see if again, if HI is 3 and OH is 4, what is the length of OI? I see those 5s over there. This is a very simple one. It's like the basic one we use. Yeah, it's a 5 here. So take that into account, right? A tangent line and a radian, and they're forming a right triangle here. The thing is, notice something. I'm going to, from this segment, the green segment, I'm going to draw this other point right here. That is part of the circumference, but is also part of the segment. Let's say the point G. Okay. So I'm gonna give you a couple of seconds while you realize what that is. Before telling me the length, what is OG? Again, here we have this. OI is 5, all right? But what is OG? What are we talking about when we talk about OG? Anyone in the chat box? Oh yeah, I just saw it. It's a radius, right? Length is the same, so the length OG is 4. So if you want to tell me what GI is, it's simple, right? Because we know the big one here, that is 5, and OG is 4, so GI is going to be 1 unit. And hopefully we all agree with that, right? Okay. So OG is the same as OH because both of them are radii. Okay. OI is 5 because it goes from the center. It's gonna be a little bit more complex in a way that we will have to solve an equation. Okay. So now I think it's time for me to erase here, but I did this like just by hand. Okay. So let's erase this. So this is an example that works like this. And yeah, no, it's okay. I'm going to draw a tangent line, right, with a point located here, and this point is point S. Okay, and this circle that has a center right here at O. So we're going to connect point S that comes from the tangent line with O with S with the center, right? So we got this, okay? And this is a point of tangency, right? And let's say that it's point H, okay? So now with that, we have this triangle right here. And what information do we have? Hopefully, and this is what we're going to do, right? I'm going to give the information and I'm going to give you 1 or 2 minutes so you try to find out what we need to find out here, okay? So we are given this information. So HS is 36, okay? So this distance right here, okay? And I want you to notice something. Now we've got this intersection right here between this segment and the circumference or the circle, and this point, let's say it's point B, now R, right? So point RS, okay? Sorry, no, so the length RS we are given is 20, right? So, okay, take a minute, okay? Find that out. Find R. What do you think we should do? Okay, 1 minute, and I will have enough time to go for my black marker. Okay, so find R, guys. Okay, I'll be right. You realize that we have a triangle here, and this is a special. Sorry, this is a. That means that I just have to set it up that way. What does that mean? I know by the Pythagorean theorem that OS is the hypotenuse, right? OS, actually I'm going to use just the length. Okay. All right, I already have an answer. Great. Let's see if it works. Let me see. I have another value here. Well, wait a minute. We'll get to it and see if it worked. Okay, right? So, okay, hypotenuse OS square equals HS square plus OH square. Okay. So now let's just plug in what we know. What is OS? It's R, and RS is 24. All right. So OS is actually R plus 24, right? So R plus 24 squared, right? Hope it's making sense. Squared plus what is OH? OH is R, so R squared, okay? That is what I get out of modeling the situation using the Pythagorean theorem. Now I have, a quadratic equation. So the thing is trying to find out the best way to solve it. In this case, let's see. I think the best way is, expanding this and see if we can make it. I remember I can either try this. I will have R squared plus 48R plus, because remember it's 24 times R times 2, 48R, and 24 squared is 576 equals 36 squared. I got it here, 1296 plus r squared. Okay, so I already expanded this. This is what I get. Then I just saw, and I'm good. So now I just have these two, you know, and it's now a very easy equation to solve. So I just need to subtract 576 on both sides. So let me continue over here. Oh yeah, I have no space here. So we have a 48r equals 1296 minus 576. I got it here. It's a 720. And then last step, right? Just have to divide by 48. Okay. With that in mind, r equals 15. Okay, so r is 15. Okay, so let me see what the answer was. Okay, well, now you can check Zach and see, you know, what the problem was. But this is one way to solve this type of, you know, situations. But because we triangle, so it means that here we're forming a right triangle. You know, as you understand that, then you can model the situation using the proper tools. Okay, so first, good. Now we, the theorem I'm going to refer to can be found one. Okay, I'm going to solve a second exercise from section 10.1, and then I'm going to jump to section 10.2. Okay, so all right, let me erase this. Now we have another circle, and there is an exterior point. I can draw two tangent lines that go to this circle C. Okay, so I can do this, right? This is a tangent, and here we go. We have another tangent here. So two tangents that have a common exterior point are congruent. Okay, so if I have this point right here and this point right here, A, B, so I know that AR is congruent to BR, right? With that in mind, I will know that the lengths are going to be the same. So this exercise is telling me that BR is 61 and AR is 7x minus 23. So in this case, we just have to find x. All right, find the value of x. So since I already know that these two segments are congruent, so I can say that AR is equals 61, and I just have to solve the equation. Okay, so 7x equals 84. So we divide by 7. X is 12. All right, and I'm done. That's it. Okay, but again, taking into account that exterior point to the circle, then you just have to set them equal to each other, and that's what we actually did. Okay, now I'm going to jump to section 10.2. It's pretty brief, simple. We just talk about minor and major arcs, and that's all. Okay, so section 10.2. By the way, just so you know, for your information, I decided to not include lesson assignments this time, where you have to answer the questions. The only thing you will have to do is your big. So we have circle C. All right, circle C. And from circle C, we're going to locate 2 points. Well, actually 3. Okay, we're going to talk about A, B, and C. Okay, so let's draw the radii. Okay, and I want to make sure that I have this. The angle that goes from A to B, yeah, this angle right here, I am kind of sweeping all this region, right? That goes from B to A, okay? In that case, I'm going to use this notation, right? So, well, I can do AB or BA, it's okay, but you know, I want to be consistent with this. So BA is what we call the minor arc. Okay, that's it. Because I'm gonna try to go around the circle and then I try to go back to B. Okay, but just this portion, this is the minor arc, and you see it's the minor portion of it. But now, if I want to describe the rest of it, the other portion, what we call the major arc, the way I describe it is by doing this. I go from A, I'm sorry, I have C and C. Let's use a different letter. So I need to use 3 letters to describe major arc. So the major arc will be A, D, and B, okay? That's how I describe the major arc. Remember that when you have the total circumference, yeah, you have 360 degrees. We're talking in terms of degrees here. When you get to you know, further courses and high and right, the whole thing is 360 degrees, and based on that, we're going to partition, you know, cut it in different 180. When I do this whole thing is 360. And based on that, we have a couple of exercises, okay? So I'm going to explain so I'm going to do one example, all right? And then after that, we will call it a day, okay? So how does this go? So actually, I think, no, I'm going to use a different one, okay? I'm going to draw a different circle. So here we are. We've got this circle M, right? So from circle M, we have A and B. We also have another radius over here, and they happen to be perpendicular, okay? And also, we have this other radius that goes to this point D, and you see we need to find out, oh, wait a minute, C, D, A, and also I changed the letters I was using here and the exercise, so I need to be careful. Okay, and I need to find out B. Take a moment to think about it and tell me, okay? I want to see that in the chat box. So CD. Okay. Do you get it? You want to try and give me some of those values in the chat? Okay. So I'm just going to solve it, and then we'll be done, okay? So CD is a minor arc. Remember, can you see, the difference between minor and major arcs is minor arcs use just 2 letters and major arcs use 3 letters. So if I want to find out CD, you might think, oh, CD, but be careful because this is a major arc, and if I wanted to find out this one, I should have included A here, which is not the case. So CD is this arc, and we have a 90-degree angle here, so we also have a 90-degree angle. So it's going to be 90 plus 35, which means that is going to be 100. This whole thing is easy because you can count on this 90 degrees here and then the 180 or 90. Okay? And finally, BAD. BAD, right? So in that case, it's like you go, this is 180, and you get to this point. So it's like you kind of cover the whole circumference except by this 35, right? Because this is how we started. So this is 360 minus 35. It's actually 325. Okay? And that's all. You only have to do the big ideas math assignment plus the quiz. You no longer have to think about the lesson assignments. So it's going to be your responsibility to read the chapter. So that me an email if you have questions. Please let others know that we are now on this thing. Will quizzes on Canvas have due dates? No, but I would recommend that you do those quizzes as soon as you can, Tom. They're not set with a due date. I'm going to do it just for a matter of helping you manage your time. But if you cannot do it for whatever reason, it will be available, okay? Thanks for your question, Tom. Thanks for your participation, guys. And I think that we're good. Okay, I'm going to